All right, hey guys, we're back ready for lesson number 9, talking about estimating roots. And this word estimating means to find a close value, but not the absolutely correct value. You're going to find something close. And we're going to make this even easier today because we're going to do this with a calculator. So let's look at some of these questions. The first one says, this is talking about Sir Isaac Newton getting hit in the head by an apple. And this is how far above him that apple was. It fell from a tree that was 25 foot tall and it came in and hit him on the apple. So we're going to find how long it took the apple to fall. That's what our job is. And it lines out what steps we're going to take to do that. So the first thing that we have to do is take the square root of 25. And hopefully if you remember the square root of 25, what it's asking me is what two numbers can I multiply together to get 25? Well, hopefully you remember that you can take 5 times 5 to get 25, and that you can take a negative 5 times negative 5 equals 25. Since this is talking about how far an apple fell, it can't be the negative value because something can't fall a negative 5 feet. So it has to be the positive value of 5. So the square root of 25 is 5. And now it says to use this formula, h stands for the height. And we know that the height is 25 feet above his head. So this h can then be replaced with the radical 25, or the square root of 25, because that's how far. So this h is 25 because that's how far the apple fell. So what I have is the square root of 25 over 4. And if you remember, we just solved the square root of 25 right here. The square root of 25 is 5. So really, it would be 5 over 4. And that would be my answer. How long did it take the apple to fall? Well, it took 5 over 4 seconds, because that's what we're measuring, time in seconds. Or I could turn that into that's an improper fraction right now. I can turn that into a mixed number. 4 goes into 5 one time. 5 minus 4 is 1. So I'm left with a 1 1/4. It takes 1 1/4 seconds for that apple to fall. Okay, now we're going to say, suppose you have another apple, and this apple was a little bit lower on the tree. This apple was only 13 feet above the ground. So now in this equation, I replace the h with 13. And it says, use the formula to write an equation representing the time. Well, we know that the time in seconds is the radical height over 4. That's what it told us the equation was. Time equals radical, however far off the ground it is, over 4. So in writing this, I would have radical 13 over 4. Now it says, can you write radical 13 without a radical sign? Well, the answer is going to be no, unless you use a decimal. We could write radical 25 as 5, but that's because it was a whole number. It made this nice, pretty 5. It was called a perfect square. Radical 13 is not a perfect square. If I take radical 13 on my calculator, I come up with a number and a decimal, which means that it's not one whole number that makes radical 13. And if you don't believe me, here's the calculator. Let's go ahead and do that. So I'm going to take the radical 13. Oops, let me delete that and put a 1 in there. And the radical of 13 equals this big long decimal. It is not a pretty perfect whole number, so it is not a perfect square. Okay? So let's go on and look at the examples. Over here it wants us to estimate radical 81 to the nearest integer. Well, I had to think, what numbers are close to 81? I'm sorry, 83. Oops, I skipped a part. Sorry about that. Let's go back up here. Sorry. This says radical 8 is not a whole number because 8 is not a perfect square. No two numbers when multiplied together, will give me 8. So I have to think, where will it belong on the number line? And what is it going to be closest to? Well, if I think of perfect squares, my perfect squares are going to be, and if I just started through them, 1 times 1 is 1, so radical 1 is a perfect square. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, and 9 times 9 is 81. So here's a list of perfect squares. These are all things that I can take nice, pretty whole numbers and multiply them times themselves to get these numbers, okay? So if these are my perfect squares, 8 doesn't fall in there. But I know that it's somewhere between here and here because that's the two numbers that radical 8 is in between. It's in between a radical 4 and a radical 9. So on a number line, radical 4 is the same as 2 because the square root of 4 is 2 and the square root of 9 is 3. So I know somewhere between 2 and 3 radical 8 has to be. And since 8 is closer to 9 than it is to 4, then my answer is about right in here. Your estimate might be a little bit different as long as it's somewhere between this number and this number because 8 is closer to 9. Okay? Let's do another one over here just to make sure we have it. Let's say that I want to find I want to put on the number line a radical 10. Well, if I look over here in my perfect squares list, 10 is nowhere on there. But I know that it's somewhere between a radical 9 and a radical 16 because that's the two numbers it's closest to that are perfect squares. Radical 9, the square root of 9 is a 3. The square root of 16 is a 4. So I know that somewhere between 3 and 4 is going to be my radical 10. This was radical 9. This is radical 16. The square root of 16 and the square root of 9. So if I broke this into fourths, I'm going to break between 3 and 4 into fourths. So I have 3.25, 3.5, and 3.75. I want to know, is radical 10 going to be closer to this side or is it going to be closer to this side? Well, you have to ask yourself, what is 10 closest to? Is 10 closest to 9 or is 10 closest to 16? Hopefully you know that 10 is closest to 9, so my answer is going to be somewhere right in here is my radical 10. Okay? And I can check that if I do that on my calculator. If I take the radical 10, my answer is 3.162. And if I look at my number line, well, there's 3.25, so it's a little bit less than that, and that's exactly where I put my dot. Okay? So now let's look at another one. The next example is that same thing. You are trying to decide where radical 83 would go. So you find the two numbers that are perfect squares that it's between. Well, now let's look at cube roots. Cube roots are not any more difficult than square roots, but they're something that we don't see as often, so they're not something that we're very familiar with. But hopefully you remember Mr. Neugebauer talking about cube roots, it's very difficult to say, is when you have three numbers that when multiplied times itself 3 times, you get that answer. So if I do my perfect cube roots, well, here the cube root of 216 is 6, the cube root of 343 is 7, so I know that 320 has to be in between those, and 320 is closer to 343 than it is to 216. Same concept, only now we're doing it with cube roots. So let's look over here. Another way that you could do this is by using a calculator. I would like for you to try to do this without the calculator. Try to do it the way that we told you, in that what it's between. So on this one, the radical 35, if I look at my perfect squares list, I know that the radical 35 is between, so I'm going to write between radical 25 and radical 36, because that's the two perfect squares that radical 35 comes to. And then go ahead and circle radical 35 because that's the one it's closest to. Make sense? Go ahead and try out the rest of these and see what you come up with. Example 3. This is when we're going to apply our information. He wants to buy a fence, so he's finding the perimeter. So I have a radical 2 plus a radical 2 plus a radical 2 plus a radical 2. Because there's 4 sides to this dog pen that he's going to make. And he needs to know about how much is he going to have to buy. Well, how many sides of radical 2 do I have? I have 1, 2, 3, 4. So that's where I get 4 sides of radical 2. Okay? And I want to know how much do I need to buy. Well, radical 2 is between radical 1 and radical 4. Hopefully you know that radical 2 is closest to radical 1. So if I answer that, if I have 4 times radical 2, you know that radical 2 is almost 1, but not quite. Because if you remember over here, radical 10 was almost the same as radical 9, but not quite. It was a little bit bigger than that. So radical 2 is going to be a little bit bigger than radical 1. Calculator, and solve radical 2. You would get 1.414. If I use that information, it's about 1.4. So about 1.41 is what it dropped it to. And if I take that times 4, because I have 4 sides of that, I end up with this. If I can't buy 0.6 of fence, what's the closest whole number that 5.6 is closest to? Well, the answer is 6. 5.6 is about 6. So he needs 6 meters of fencing. About. He's going to use a little bit less than that, but he will have enough to do the entire length of his dog pen. Okay? Here's another problem, and it says 1 plus radical 5 over 2. Well, we can take care of that radical 5 by doing it on our calculator. So if we have a radical, if we do radical 5, is that number plus 1, so I'm going to add 1 to that, is this number. And then if I divide that by 2, I get 1.618033989. I'm going to round that to the nearest tenth because it says to estimate the value, which means I don't want an exact answer. So that would be 1.6. I know the book has 1.5, but because we did it on a calculator, our answer is more precise. So the answer that you should have is 1.6, because if I take the radical of 5, I take the square root of 5 plus 1 divided by 2, I get this answer. And if I round that to the nearest tenth, my answer is 1.6. All right, make sure you guys write down any questions. Use your calculators. If you don't have a calculator, please come see Mr. Neugebauer or myself tomorrow so that we can get you guys hooked up with that. Also, make sure that you write down any questions that you have in the columns and make sure that you ask them in class. We can't help you if we don't know what the problem is. So be prepared to come in tomorrow and do some work with some square roots. Talk to you tomorrow. Bye.